Hello students, I am Prem Dhawan and I will be discussing with you some more reactions of phenols in this video. But before I start, please subscribe to my channel if you haven't already and press the bell button so that we can notify you whenever the next video comes. Let us discuss two important name reactions of phenols, and the first reaction is the Reimer Tiemann reaction and the second Kolbe reaction. And both these reactions are examples of electrophilic substitution reactions of phenol involving replacement of the hydrogen of benzene ring by some incoming electrophile. So, we will start with Reimer Tiemann reaction first. Now, first reaction is Reimer Tiemann reaction. Now, what is Reimer Tiemann reaction? This is a method to prepare phenolic aldehyde like salicylaldehyde from phenol using chloroform and alkali at 60 degrees Celsius followed by hydrolysis. And the alkali used in the Reimer Tiemann reaction can be either sodium hydroxide or potassium hydroxide. Now, this is the reaction involved. This is our starting compound phenol is being treated with sodium hydroxide. It gives a sodium phenoxide. This is sodium phenoxide, and sodium phenoxide on treatment with chloroform at 60 degrees Celsius gives this an intermediate. And this on hydrolysis with NaOH gives and this on acidification with a hydrochloric acid gives the final product called a salicylaldehyde. Now, this product is called a salicylaldehyde. And also named as orthohydroxybenzaldehyde and its IUPAC name is 2-hydroxybenzaldehyde. Now, if you look at this reaction, the one hydrogen of phenol has been replaced by a CHO group. Now, this reaction is called electrophilic substitution reaction, and the ortho product is the major product in this case because ortho product has a intramolecular hydrogen bonding. So, this salicylaldehyde has intramolecular hydrogen bonding. And as a result, salicylaldehyde is a steam volatile. Now, the next is since this reaction is an example of electrophilic substitution, we should know what is the electrophile in this reaction. Now, when chloroform reacts with the alkali, sodium hydroxide or potassium hydroxide, it forms NaCl and it forms CCl2. Now, if you look at CCl2, its name is dichlorocarbene. And in this case, the carbon has only 6 electrons. So, this carbon is electron deficient. So, this dichlorocarbene is an electrophile in the Reimer Tiemann reaction. Now, we will see the mechanism of this Reimer Tiemann reaction. Now, this is the mechanism involved in this reaction. Now, our starting compound is phenol, and phenol first neutralized by NaOH alkali, it gives a sodium phenoxide. Then it combines with electrophile, which is our CCl2, like this. So, this negative charge participates into resonance and the orthocarbon acquires a negative charge. This orthocarbon then attacks at the carbon of the CCl2 group. And then we hydrolyze this by using water. It forms this product. But this product is non-aromatic, it is a ketonic form, so it will rearrange itself to form a phenolic group or phenolic compound. Then we hydrolyze this using NaOH, and see in this compound the chlorine is on the side chain. The chlorine is not directly bonded to the benzene ring. So, this chlorine is easily hydrolyzable by NaOH. But at the same time the NaOH also neutralizes the phenolic group. And the last step is hydrolysis with the dilute HCl. So, this is the mechanism of Reimer Tiemann reaction. And this reaction involves the formation of a new carbon-carbon bond between the benzene and the carbon of the CHO group. This is a Reimer Tiemann reaction. So, many questions can be framed on the Reimer Tiemann reaction. Like first example, write a short note on Reimer Tiemann reaction. Second question, how do you convert phenol into salicylaldehyde? So, this is a conversion. I can also frame a question like fill in the blank. Phenol is being treated with chloroform alkali, write on the structure of A. So, many questions can be framed on Reimer Tiemann reaction. Now, second reaction is the Kolbe reaction. Now, this is also a very important reaction of phenol involving benzene ring. Now, Kolbe reaction is a method to prepare a salicylic acid from phenol using carbon dioxide, dilute NaOH at 400 Kelvin and followed by hydrolysis. Now, this is the reaction involved. This is our starting compound phenol. First we treat phenol with NaOH. It gives a sodium phenoxide. And sodium phenoxide on reaction with carbon dioxide at 400 Kelvin gives a sodium salicylate. Now, this is sodium salicylate. And sodium salicylate on hydrolysis with a dilute HCl gives a final product called salicylic acid. Now, this is called salicylic acid. And has a common name orthohydroxybenzoic acid. IUPAC name is 2-hydroxybenzoic acid. Now, again if you look at the reaction, in this reaction the benzene H has been replaced by a carboxylic acid group. So, this reaction is also an example of electrophilic substitution reaction, and in this case carbon dioxide carbon carrying a partial positive charge and is an electrophilic center. Now, this is the mechanism involved in Kolbe reaction. Now, this is sodium phenoxide. Now, this negative charge of oxygen participates into resonance with the benzene ring. So, orthocarbon then acquires a negative charge, and this orthocarbon then attacks at the positively charged carbon of the carbon dioxide. And gives this product. And this product is non-aromatic, so this will try to regain aromaticity like this. And this is called sodium salicylate, and this sodium salicylate on reaction with the dilute HCl finally gives the salicylic acid. This is salicylic acid, and if you look at this reaction also involves the formation of a new carbon-carbon bond. Now, once the salicylic acid is produced, this salicylic acid can be changed into two other very important products. So, these are the two very important reactions of salicylic acid. Now, this is salicylic acid. And the first reaction is reacting it with methyl alcohol in the presence of sulfuric acid. Now, this reaction is called esterification, and it gives an ester called methyl salicylate. This ester is called methyl salicylate. Its another name is oil of wintergreen. And used as a pain reliever. And the side product is H2O. Now, second reaction is, this is called acetylation of salicylic acid. So, you can use either acetyl chloride or you can use acetic anhydride for acetylation of salicylic acid. It gives an ester. This is ester produced, and this ester is named as 2-acetoxy benzoic acid, and the side product in this case is either hydrochloric acid if we are using acetyl chloride, or the side product is acetic acid if we are using acetic anhydride for acetylation. And this 2-acetoxy benzoic acid has a commercial name called aspirin. And this aspirin is used as an analgesic, pain reliever, as well as antipyretic to lower the body temperature in case of high fever. So, aspirin is a pain reliever, as well as lower the body temperature in case of high fever. So, these are two very important reactions of salicylic acid. So, Kolbe reaction also involves the formation of new carbon-carbon bond, and again many questions can be framed on Kolbe reaction also, like how do you convert phenol into salicylic acid, what happens when, write a short note on Kolbe reaction, or we can use these type of conversions also, convert salicylic acid into methyl salicylate, convert salicylic acid into aspirin. So, many questions can be framed on Kolbe reaction also. So, these are two very important name reactions of phenol. That is all for this video. I hope you got to learn something new, and if you did, then please press the like button and share this video with others. Also, if you have any doubt, any question, please note it down in the comment section. Thanks for watching. See you next time.